Have you ever really looked at the box your phone came in or the soda can in your hand? They seem pretty simple, right? But they're actually shaped by this hidden math, a principle that literally saves companies millions of dollars. Today, we're going to unpack that unseen math that kind of builds the world around us. And it all boils down to one simple question.
Okay, let's put you in the driver's seat. Imagine you're about to launch a brand new sports drink. Awesome, right? But hold on. Before a single can even gets made, you have to answer this massive question. How much aluminum do you actually need for each one? Because if you use too much, you're just throwing money away. Use too little, and, well, you don't have a can. This right here, this is the billion-dollar question that pretty much every single manufacturer has to face.
All right, so here's our game plan for this explainer. First, we're going to unpack the big idea, what surface area even is. Then, we'll build ourselves a little toolkit for the most common shapes you see every day. After that, we'll see how this stuff works in the real world, and we'll wrap up by making sure you can master the math and sidestep all the common mistakes.
Okay, so first things first, before we can start calculating anything, we gotta get a handle on the basic concept that's at the heart of all packaging design. So, what exactly is surface area?
All right, put simply, it's just the total amount of space covering the outside of a 3D object. Think of it this way. If you could unfold it and lay all its sides out flat, the total area of that flat pattern, that's your surface area. Mathematicians have a cool name for that flat pattern. They call it a net. And this is a perfect way to picture it. Imagine you carefully unglue a tissue box right along the seams and you lay it out totally flat on a table. All that cardboard you're looking at? Yep, that's the surface area. It's literally the skin of the object.
All right, now it's time to build that toolkit I was talking about. We're gonna break down the 3 shapes you see everywhere in packaging. You know, your basic boxes, some fancier ones, and of course, cans. We're talking rectangular prisms, triangular prisms, and cylinders. Let's get the exact tools we need to tackle each one.
Okay, tool number 1 is for the shape you see the most, the classic box, or rectangular prism. Super simple, right? It's got 6 sides, and they come in 3 identical pairs, a top and bottom, a front and back, and a left and right. So the formula just does this. It finds the area of one of each pair, length times width times height, length times height, and then just doubles each of those to get all 6 sides covered. Easy.
Let's actually put this to the test with our tissue box. So first up, we figure out the top and bottom. That gives us 96 square centimeters. Next, we do the left and right sides. That's another 60. And finally, the front and back, which is 80. Now for the easy part, you just add all those numbers up.
And boom, there you have it, 236 square centimeters. That means to make just one of these tissue boxes, you need exactly that much cardboard.
Okay, on to tool number 2. This one's for those cool triangular prisms. Think of a Toblerone box. Now what's kind of different here is that there's no single neat formula to memorize. It's more of a method, a reliable step-by-step process that always works. And this method is basically foolproof. Here's how it goes. First, you find the area of one of the triangles at the end. Then, you double it, because you have 2 of them. Simple. After that, you find the area of each of the 3 rectangular sides. And the last step? Just add all 5 of those numbers together. That's it. Nice and systematic.
So, for the example we were looking at, once you follow all those steps, you land on a total surface area of exactly 300 square centimeters.
And now for our final tool, the cylinder. Just think of any can of soda. The cool thing about a cylinder is if you could unroll it, what do you get? You get 2 circles, the top and the bottom, and 1 big rectangle that was the label part, the curved side. And the formula totally reflects that. It's just the area of those 2 circles plus the area of that 1 big rectangle. All right, let's actually calculate a standard pop can. Now listen up, because this is super important. The formula needs the radius, not the diameter. The radius is always half the diameter, so don't trip up on that. It's a really common mistake. So once you've got that radius, you find the area of the 2 circle ends, then the area of that rectangular side, and just add them up.
And that gives us our grand total, 309.6 square centimeters. Think about that. That's the absolute minimum amount of aluminum you need to make just one of those cans.
So, okay, we've got our toolkit, we know how to do the math. But why does any of this actually matter in the real world? Well, this is where the math meets the money. This isn't just theory. Companies use these exact calculations to make huge financial decisions about their packaging.
Let's do a little head-to-head competition. On one side, we have a box. On the other, a cylinder. Which one do you think uses less material? Well, we run the numbers for the box, and we get 208 square centimeters. Then we do the math for the cylinder, and look at that, it's only 149.2. That's a big difference. And you can see it plain as day right here. The box needs way more material than the cylinder to get the job done. Now just imagine, multiply that difference by, say, 1,000,000 cans, or 10 million. All of a sudden, you can see how just choosing a different shape can save a company an absolute fortune. Okay, so we've covered the what, the how, and the why. So for this last part, let's make sure you really walk away a pro. We're going to look at the common traps people fall into with this stuff, and more importantly, how you can easily avoid them. All right, here are the big four mistakes you want to watch out for. First, mixing up area and surface area. Just remember, area is one face, surface area is all the faces. Second, for prisms, people sometimes forget to double the pairs of faces. The formula has those 2's in it for a reason. Third, and this is a big one, using the diameter for circles instead of the radius. Always, always cut that diameter in half first. And last but not least, don't round your numbers too early. Wait until your very final answer to round off. It'll be way more accurate. All right, let's do a super quick recap of the essentials. 1. Surface area is just the total skin of an object. 2. We've got our tools for the big 3 shapes, the rectangular prism, the triangular prism, and the cylinder. And 3, and this is the most important part, this isn't just abstract math. These calculations have a huge impact on real-world costs for pretty much everything we buy.
So I'll leave you with this one last thought. The next time you're at the store and you pick up a box or a can, just pause for a second. Take a look at its shape, because now you know how to see the invisible math that's hiding right there on its surface.